Determine the surface area of this composite object. So if we look at this object, we see we have a cylinder on the bottom. So I wrote down cylinder here, and we have a hemisphere sitting on top. So now when I'm referring to the surface area, think about if you were to paint this object. So what part of the area or the shape are you painting? So we would need the bottom. We would need this lateral area of the cylinder, and we would need the lateral area of the hemisphere. So we don't need the base, because the base of the top rather, maybe would be a better way of saying, the cylinder and the base of the hemisphere are touching that part you don't need. So the surface area of the cylinder, I'm going to just start with looking at that formula here. I got that off of our formula sheet right here. So I wrote it down here for us. Now the 2 pi r times height is the lateral area. In other words, that's that area, this circular part right here. Area of the base is 2 pi r squared is the top and the bottom, but I only need part of this. I'm only painting the bottom. So it's 2 circles. That's why it's 2 pi r squared. So I only need one of the circles. So when I'm going to put my formula together for this shape, for the surface area, I'm just going to use 2 pi r times height. So the lateral area, plus, instead of 2 pi r squared, just pi r squared. So this is going to be the lateral area. This is going to be the bottom. Okay. Now let's look at the hemisphere. Remember that the formula for surface area of a hemisphere is 3 pi r squared. Now, where did that come from? I'm just going to refresh your memory. We had looked at this earlier, and surface area is cutting that hemisphere in half. So the lateral area is 2 pi r squared, plus the area of the circle on the top is pi r squared. Well, I don't need the pi r squared anymore because I just need the lateral area. So I'm not going to take off the area of the base, because the area of the base, I'm not painting that part. That would be just on top. Okay, so that would mean that this really, I'll break this down so we have it here for you. This is the lateral area right here. And this is the area of the base. But in our formula, we only need this part. So we're going to say plus 2 pi r squared, which is the lateral area of hemisphere. All right, so we can plug all our numbers in. I like to try and keep things a little bit simpler in terms of grouping things. So if I have a pi r squared plus a 2 pi r squared here, I like to combine that. I don't have to, I can plug the numbers in, but I see that as 3 pi r squared. So I've kind of derived my own formula for my object here. Okay, let's plug in some numbers now. So 2 pi, radius is given as 2. The height is given as 4. Plus 3 pi, we're gonna put that radius back in here and square it. So let's just simplify this in our head first. So 2 times 2 is 4, 4 times 4. So we've got 16 pi. This allows us to not have to type so much in our calculator and less room for rounding errors. Plus 2 squared, you have to do your exponents first, is 4. 4 times 3 is 12 pi. So you have 16 pi plus 12 pi, so you can combine those to make this 28 pi. This is actually a perfectly fine answer in terms of an exact value. In other words, 28 pi is exactly the right answer. Of course, we want to make a little more sense of that and put that into our calculators. So if you want your decimal answer, 28 pi in your calculator, you're going to get 87.96 feet squared. Now, if I didn't combine this formula and I was just trying to get my decimal answer, I can go ahead and just plug them directly in there. Just be careful with your rounding that if you are writing these 3 numbers out individually, you write down every little decimal and then punch that back in your calculator. I find this a lot less work for the calculator piece and more likely to not have a rounding error.